Hi, everyone. Thanks for joining for this session. I know the journey has been a little bit long for you, so I'm very glad to see all of you for these sessions, where we're going to explore a little bit like various branching strategy. My name is Ludovic. I'm head of engineering at NFQ. We are a company that is kind of like building softwares, but mostly products. We support companies and especially startups to build their products, and we are operating in 6 countries: Germany, Poland, Lithuania, Egypt, Thailand, and Vietnam. And today I would like to share with you a real-life experience about a project that we got that initially started with some technical decisions and ultimately had to pivot and adapt, of course. The story starts with a couple of years ago. We started a project with one of our customers, startup located in Europe. And at that time, of course, when you start a project, you take some decisions, but you don't have a clear understanding and vision about like everything, right? There is some unknowns, and then you take assumptions. And one of the very structuring decisions you usually take when you start a project is to decide about the collaboration for the team. And you choose generally like a branching strategy. How the team is going to cooperate? How are they going to work together? What kind of like strategy do we want to take? And of course, this decision will impact a lot various aspects, such as team collaboration, code stability as well, the way we handle changes, and the release management. How are we going to release the software? So when we take this kind of decision regarding the branching strategy, we need to consider that it can impact these 3 criteria I just mentioned. When we started this project, we initially went with Gitflow. Gitflow, I think it's quite like famous branching strategy. Usually, you are using a lot of branches. So, for example, you start with the master branch. Okay, the master branch will host the stable version of your software. Nobody can directly write to master. There is no way you can commit directly to master. Instead, the team will work on the develop branch, right? We will work on this orange branch, and we will introduce extra branch that we call features. And whenever I want to implement a new features, I will work on my dedicated branch, and then I will merge back to the develop branch. Okay? If I want then to release, I have another branch called release that will handle the release process, meaning the delivery and the deployment to productions. And finally, I will pull this release to the master branch to stay consistent regarding the states. Okay? With this workflow, we can already see some limitation, but you got the idea, right? What we have here is a strong isolation mechanism via branches. We want to isolate our code to make sure that when there is an impact, it does not affect everything, but only part of it, right? And for doing so, we isolate the life cycle of the software in various branches. We work on a dedicated develop branch. We work on a dedicated feature branch. We have dedicated release branch. And of course, it creates some overhead, right? In addition, in terms of choices, at that time, a very standard approach, we had like 3 different environments. We have the develop environment, the staging, and the production. Very standard, okay? And when we initially start with a fairly small team, like 5 people, then, okay. Basically, it was kind of manageable. To release, on average, it took us like less than 1 hour, basically. Each release took like 50 commits, 50 changes, so it was kind of like still like manageable. And basically, we were releasing like once every week. So with a team of like 5 people, this was the metric we had at that time. But of course, as the product scaled and you had like another team, then the things get tricky. The release time increased. Basically, we went from 1 to 3 hours. The release size as well, the batch of work that you release is also increasing. And you struggle a little bit to keep the frequency, but it's still kind of like acceptable. Of course, a couple of months later, we keep increasing this team. And this time, we went from 1 to 7 hours just to release something, which is completely crazy. The release batch is like very big, and the frequency that we keep to maintain, it costs us a lot. Meaning like 7 hours, basically, you have one guy, one FTE. His whole job for one day is to prepare the release, to fetch all the modification, to make sure it's working, to prepare the release note, to deploy it, to check. So basically, it's not super amazing, especially when you build a product and you want to iterate fast. And of course, at the end, when we reach our full potential with like these extra teams, we completely lose basically the release frequency. We were able to release like every 2 weeks. So basically, it was, of course, not desired. And the release time increased again. So we can see that starting small, it works. And quickly, if you want to achieve something with like a bigger team, it starts to get complicated, right? So here, what exactly is happening? Why do we have such a situation with our code base and the way the team are collaborating? Let's listen to what the development team is saying, right? Guys, I need to solve the conflict to prepare the release, okay? I need to test again before I release something. We need to pull the hotfix that we have to all branches, because we have fixed something, but it's in the hotfix branches, and now we have to cherry pick this modification to the rest of the branches. I need to revert a change in the release. So basically, all these kind of sayings from the developers, it's very famous, it's called the merge hell. Basically, we spend a lot of time, because of this isolation, to merge back modifications, to handle conflicts, to not forget any modification, to cherry pick. And basically, instead of like building the software as software engineers, we are kind of like trying to use and compensate this model by engineering like the Git processes. So we have one guy who became the master of Git, and he spent basically like 9 hours to prepare a release, which is like crazy. What else is happening? Yeah, we have this guy, he's a front-end dev, and yeah, he's waiting for someone to finish his job, and unfortunately, because the backend API is not ready, he will start something else instead. So we have also this guy who is waiting for the QA to test his features. The QA is waiting for the staging to be able, because we have too many people that are using the same resources. And finally, at the end, everybody is waiting for everyone. Here we have like a strong lead time, right? People are waiting for each other. People are waiting. And of course, when you lead an engineering team, this is not really what you expect. It doesn't mean that people doesn't work, because they are doing something different. They are not just waiting, but it's still a lead time that we need to fix. Why is it happening? Basically, it's happening because we have long-living branches. Because we have a master branch, because we have develop branch, because we have the hotfix, because we have the release, because each single developers, they have their own feature branches, things get complicated. Basically, when you do Gitflow, you cannot do continuous integrations. There is no way, right? It's not because you have Jenkins, CircleCI, GitLab CI that you are doing continuous integration. Not at all. Continuous integration cannot be achieved with this model for the simple reason that you need continuously to merge everything manually. There is no way you can do that in a different way. So no matter if you have like a CI server, when you apply this kind of like patterns, you don't do actually continuous integration. The second aspect that is impacting the lead time is that we have cross-dependency. Again, because we are working in different contexts with different branches, basically we have different dependencies between people. And finally, a side effect, we also have like this bottleneck on the staging environment. So how could we solve this situation? Basically, our Git merge today, they are kind of looking at that, right? It's kind of like crazy. We need to spend a lot of time to talk together. And one approach to solve this specific problem could be to apply a different strategy, which is called trunk-based development. So trunk-based development is not new, basically. Huh? It's something that we have been doing like years after years. It's basically an extreme programming approach, so it's not new. And in this methodology, in this branching strategy, basically, we are using a single branch called the trunk, or the main, or the master branch, okay? And everybody is working on this single branch. We don't have any develop branch anymore. We don't have any release branch anymore. We don't have any hotfix branch anymore. Everybody has to work on this main branch. We tolerate short-lived branch, meaning, of course, you don't have to commit directly to the master. You can open like a feature branch, But the contract is that this branch cannot last longer than 1 day. It means that you can create a branch, but at the end of the day, you still need to merge it back to master. Fourth principle, we release directly from the master branch. It means that each commit that you push to the main branch, become itself a release. Okay? So let me recap. The master branch is the single source of truth. We release directly from master. It means that every commit that we push to master is basically a release. It means that if we build and break the branch, we have to fix it. And finally, we prohibit long-living branches, meaning we can't have branches, feature branches that last longer than 1 day. Okay? At this stage, we don't care still about the environment. We keep this kind of approach, right? How do we implement that? Right? The question is, okay, it's nice what you're saying, we have a single branch, how do we do actually, right? And a couple of approach that are taken is that we need to work with small, incremental, and consistent change. Basically, every commit should be very small because it becomes something that we can release. We are not releasing a bunch of commits via a release note. Every modification can be released directly to productions. We need to encourage these short-living branches. And here you will say, okay, but if I have to merge every day, how can I handle unfinished work, right? Because we have tickets, we have stories that will last longer than 1 day. So there is no way we can merge something that is not finished. It doesn't make any sense. And here, we will need to introduce a concept called feed your flag to wrap the unfinished work. And I will introduce that in a couple of slides. So what approach did we take, and how can I recommend you to approach the trunk-based development implementation? First, we definitely need to sit with the team to organize workshop and to rework completely the mindset we have in the team. Why? Because for years, you were prohibited to commit directly to master, and suddenly, you can commit to master. It's a drastically change in the mindsets of engineers, because for so long, the master branch was, some kind of graal that you can't touch, that is protected, and nowadays, you can do whatever you want with it. So it's kind of very surprising for a lot of engineers. Secondly, okay, you mentioned we need to have small stories, we need to have small commits. How small is that? What does it mean to me small? I can guarantee that we have hours of discussion to define what is small, what is big, what is a small commit, what is a small story, but this is necessary. And finally, since when people touch master, it becomes a release, you also need to empower your people to understand that what you're doing is basically you have the power to deploy something to production. Again, some developers, they are uncomfortable with this idea. This is why these workshops are interesting and important. The second aspect as well is that you will need, if you want to go this way, to instrument and adapt your code review process. You need to rely and abuse a lot about what we call pull request decorations. Why? Because the isolation that you had before that was protecting via different layers the modification to the main branch, now you only have one step. So you need to engineer this part to make sure that when you introduce a change, it's been carefully reviewed, checked, controlled. And then it means that the review must be very engineered in terms of checks that you want to execute automatically to help the reviewer to go faster and focus on what matters. The second change as well is that we probably need as well to move to synchronous reviews instead of asynchronous reviews. When you do Gitflow or any branching mechanism, usually what you do is you change something. You have someone that will review the code, but it can take a couple of hours or even days. Of course, in this case, because you want to merge everything at the end of the day, you need to work in a synchronous way. You need to sit with your people and say, hey, look, I have done that. Could you take a look now or in less than 1 hour? It's important as well to change a little bit this mindset. Finally, we need to consolidate the build process as well. We need to make sure we have enough tests to have a good completeness, and we need to make sure that the build executes fast. If you have a build that takes more than like 15 minutes, basically this approach will be very challenging because people need a quick feedback if you want them to merge quickly and efficiently and at a high frequency to the main branch. Okay? In terms of benefit, what we observe is that, yes, this approach helps us to lower the merging effort. We were able as well to increase the release frequency, to have more stable iteration as well, because the change introduced were smaller. And it also changed a little bit the way our engineers approach problems. They were more willing to take baby step approach rather than big changes introduced. So it's also forced them to think in really, really baby step approach, the changes, and not and in particularly, it helps to include this refactoring approach. Because when you refactor, you can't change everything at once. You need to go step by step. And this approach also helps the way the engineers like perceive and solve this problem, which is interesting. So a couple of minutes ago, I was mentioning about, hey, look, we have this story that we have not finished. You're asking me at the end of the day to push to master. How is that possible? I mean, how can I do that? I mean, there is no way we can like have this like weird state where master contains unfinished work. And basically, we can do that. And actually, it's encouraged. And for doing that, we will use what we call feature flags. Basically, a feature flag is a conditional rendering on something. You will wrap your piece of code, and basically, you will push to master, and this code will contain your modification, but it will not be rendered to the rest of the users, right? It means that here, when I introduce this new blue component, basically, the blue component, the code is deployed on the main branch, on the master branch, but nobody can see that on production. To enable this feature, I will need to toggle, to click on a button, to change the Boolean state, so this component will be rendered. So it means that basically, yes, we deploy to production every day, but it doesn't mean that we release to production every day. There is a decoupling between what we push to production and what is actually released, right? So basically, this approach helps us to deploy non-ready features to production. It helps as well to enabling and disabling the feature on the runtime. If I want to disable the feature quickly, I can just like change the Boolean. I don't have to rebuild the code. I can do that in a very easy and quick way, and this is intended. And finally, I can mention, we are completely decoupling the deployment from the release. Yes, we are pushing every day to production. Yes, we are touching master every day, but it doesn't mean that we are releasing the feature. It just means that we do proper continuous integration because everyone that is using the code base see my modification, despite they are not enabled on production. Can we do that on the backend side as well? Of course. You are working on some algorithm, right? And it's not finished. It's kind of like a complex optimization or a complex refactoring. You can wrap your modification, and using a feature flag, you will not impact the rest of the users. And basically, you can wrap this way your modification, and conditionally, it will be rendered or not. Basically, doing that, you're kind of like having a branch by abstractions. You wrap your modification, but nobody can actually see or use it. So this is the purpose of the feature flag. We are also using feature flag when we want to do A/B testing, for example. It's also a concept that, for example, I will deploy a feature, and I will trigger this feature for a specific audience I want to test. It can be a specific set of users, it can be a specific set of profile, maybe some browsers, maybe the mobile app, it can be different locations. We can also use feature flag inside the code to dynamically test features and collect feedback from part of the users. So the feature flag can be used as well for these purposes. And actually, it's very common. For example, I live in Vietnam. In Vietnam, we have like Grab, which is the equivalent of Uber, to actually like book a taxi. And recently, I was in a city called Da Nang, in the middle of Vietnam. And as I was ordering a taxi, basically, I got this message. And Grab actually was beta testing feature only on this city. If I was leaving the city, the feature was not enabled for me. But because I was in this area of Vietnam, then this feature was tested and I was kind of like working for them for free, right? And I think this is very interesting to collect feedback and to kind of having a product discovery and user research approach, which is also interesting. So how do we implement feature flags? We have a way to implement that on a custom way. So it can be like very low-tech approach, environment variables. We can also use libraries. A lot of languages already implement some libraries for feature flag implementations. We can also implement our own components. Why? Because at the end, we are talking about a database that will store the state of the feature flag. We have a service that will basically expose this value and just consume it. And that's it. We can also use like a SaaS solution. I mentioned some of them that can provide also some extra like features like A/B testing. So we have different choices, and basically it's up to you depending on which use case you want to target. By the way, there is a conference tomorrow that is given on one of these solutions, Unleashed. So probably you will attend that, and I think you will get interesting like insights. The interesting as well with feature flag is nowadays we can integrate this directly in the product and the development lifecycle. For example, in Jira, you have the ability to connect to these solutions and to visualize which feature flag are enabled and which are not, which allow us in a transparent way to visualize where we are. And basically, this is a cool feature, especially for product manager, to kind of like experience and collect feedback and visualize where we are. An extra challenge that usually we ask a lot is, where should we implement feature flags? Should we only implement that in the front end, meaning on the user interface, in terms of like components, pages? Should we implement that on the API, payload, or the endpoint? Should we implement that in the business logic, meaning like in a discrete processing? So we want, like I mentioned in my example, in the backend in one service, we want to dynamically change that. Basically, it will depend on what you want to do. Most of the time, you will need at least to have the user interface in the API because you don't want someone to tweak your system and be able to exploit, for example, something that should not be there, right? So here, a very important aspect to consider is the security aspect and also the testability aspect. We are still introducing some code, despite it's not enabled. So we need to make sure that nobody can access it, unless it's explicitly authorized. And secondly, we need to test it. It's still code. You are still pushing some code, so it means that you need to test it. You need to test if something is working as expected in case the feature flag is enabled. You also need to test it in case the feature flag is disabled. There is no way you can push this feature flag to productions if you have not tested all the cases that are supposed to happen. There is no way you can do that. Okay? Again, despite if you are doing everything correctly, things can go wrong. And I think this is a very famous failure case about feature flags. We are talking about like a company, unfortunately, that does not exist anymore. They were basically one of the leaders in trading in US. So basically, they, in 2012, they were kind of like having like one of the biggest trading mechanism on the US stock exchange. And because the regulation changed, they implemented something new in the code. And one day, they released these changes. And these changes was impacting a feature flag. Okay, so in detail, what happened is like the regulation changed in the US, so they implemented a new version of the algorithm, and they wanted to do things properly, right? So they say, okay, let's have a feature flag, and we will roll out the modification step after step. And the idea is not to go like with like full life, but the idea was to deploy the code step after step and making sure that everything is all right. The code has been tested, the feature flag has been tested, so everything was done properly. Unfortunately, they did a small mistake that cost them a lot. Basically, they reuse an old feature flag. And they were supposed to deploy the code on 8 servers, so the new version of the code. Unfortunately, they missed 1 server. So the new piece of code was deployed to 7 servers. The 8th server did not get the new version of the code. When they enabled this feature flag on all the machines, the system got crazy. In 45 minutes, they have lost $500 million because one of the machines that did not receive the new version of the code started to act crazy by buying a lot of auctions, tradings, and of course, it was not expected. The worst thing is that they didn't understand what happened, right? Because suddenly, the market just like crashed, and later on, they discovered that the problem was at this level. So with this mistake, the company just got bankrupt because they basically lost like $400 million just because of this mistake. In 48 hours, they had to compensate these losses by having investment. Unfortunately, they couldn't make it in a proper way, and now this company does not exist. They have been bought by another company. So feature flag can also go wrong despite you are doing everything. Despite it's like tested, despite you know what you're doing, be careful, it may happen. So a couple of recommendations when we are using feature flags, right? Use them as little as possible. What means littles, depending on your team size, but if you are working on different domains, you should not have like more than maybe 5 feature flags per domain, so you need to pay attention at that. You need to place your feature flag as high as possible. So again, we don't like to have like a series of feature flags that are like wrapped together, but instead put them as high as possible. The feature flag need, of course, to be battle tested. You need to test them, like I mentioned. You need to make sure they are working the way they are supposed to work, if they are enabled, and also if they are disabled. Feature flag need also to be documented. What it means that you need to describe how do we enable the feature flag, how do we disable it, what is the internet effect, what is the impact when we enable, when we disable, who is responsible for the feature flag, and when this feature flag will be removed. This is what we call documenting the feature flag. Whenever we introduce a feature flag, especially in this team, this is the approach we are taking. We describe, okay, we want this feature flag because this is the feature we want to kind of like control. Who is going to be responsible to enable or disable? What is going to happen? We describe everything to make sure that in case something wrong happens, everybody has the knowledge to act in consequences. This is super important. Okay? Of course, we need to remove them when it's finished. There is no way you can keep a long-living feature flag. There is no way. You have to remove them at some point because it's really like a temporary approach. Finally, never, never, never recycle them. You can't reuse them for no reason. You need to create a new one, and you need to forget about the other ones. Otherwise, you could create some very weird stuff in case somebody did not respect the previous rule I just mentioned. Okay? What did happen to us once we have been using this feature flag? Basically, we start to drastically reduce the cross-dependency. Why? Because, okay, the backend is not ready. This is fine. I have finished my work. We are going to review it. I will put a feature flag on this UI feature. And you, backend guys, whenever you are ready, you can use these changes. You can pull locally. You can use that. And you will be able to use my feature to test it. And if everything is right, we will enable that on production. So by using feature flag, we are removing dependency. People don't need to wait for each other. We can just release whenever it's ready, deploy into production, and the rest of the team will be able to play with this feature later and enable them on production later as well. So it's very powerful to remove cross-dependency. Feature flag also help us to enable true continuous integration for the same reason I just mentioned. You provide transparency on your code because you merge frequently and you push your changes. So it means that everyone knows what you're doing, and you can wrap your modification using this feature flag, but at least people are aware of what you're doing. So it provides true continuous integration. Finally, this approach also helps us to tackle more a product research mindset. Thanks to the feature flag, the product managers, the development team, they start to be much more tactical in the way they were releasing feature. They were starting to have like very nice conversation. Maybe we should try that. And if it's working, then we can go a little bit further. If it's not working, we don't have to invest a lot of time. It's not really a problem. We can disable it very quickly. We can target a specific audience. So this kind of approach also helps to have a very healthy conversations in the way we kind of like try to collect feedback and get a product research mindset, which is very interesting, especially when you develop such kind of like products that need to iterate fast, and when you don't know very where you want to go, but you need to pivot very quickly. So now that we have solved the problems, some of them, so we have solved basically the merge hell, we would like now to tackle the lead time that I just mentioned. We already have tackled some part of the lead time because we have removed cross-dependency thanks to the trunk-based development plus the feature flag. But there is still this problem with the testing environment when everybody is waiting for each other, right? And I would like to explain a little bit what exactly is this problem. So we have different teams, and basically, all these teams, they are using the same staging environment and dev environment to work. And of course, this is not awesome because it creates a lot of like bottleneck in the way that, okay, I want to use it, can I use it? No, you can't, okay, I need to wait. And of course, it's not really awesome. The complexity as well is to operate this environment because they are kind of like very specific. And now that we are moving to a trunk-based development, we also wanted to tackle this problem. Basically, the idea is that this time, we will keep using this trunk-based development approach, but instead of having to maintain an environment, which is called staging, we will build directly at the branching level a full environment. We want to offer the opportunity to our developers to build completely an environment that contains only their modifications. So it means that basically, we are building a full environment that is very close to productions and that contains only the modification on this branch, right? And when I say everything, it means that as a developer, I want to have the backend, I want to have the front end, I want to have the crons, I want to have the queues, I want to have the dependency, the third parties, and I want to have my own databases. And I don't want to share that with anyone, and this environment should contain my modification, right? So here the idea is that we build an environment that contains only the branch modification. For doing that, we need to tackle a first problem, which is the multi-tenancy. Basically, instead of using a shared environment called staging, now we need to build dynamically and host different environments in such a way that they are completely isolated. The way we tackled this problem was to use Kubernetes and especially rely on the namespaces of Kubernetes. So basically what we did is like we build everything, we deploy to Kubernetes in a dedicated namespaces, and using the Kubernetes abstractions, we are able to offer dynamically an access point to, for example, the feature environment. We use the Kubernetes ingress, and we will say, look, you are working on the feature number 1, then this is the URL to access your environment. And you will be able to use your databases, your front end, your crons, your queues, perfectly isolated. We went a little bit further than I display here because we also have done that with all the dependencies and the third party that have been used. It means that today, when a developer starts this feature environment, he will have his own observability stack, meaning he will see the logs, but only his logs. He will see the metrics, but only his metrics. He will have a proper isolation on the payment gateway, meaning that if he needs to identify the payment transactions, he will only see the transaction from his space. So we also have work to isolate completely all the dependencies and all the third parties to make sure they only belong to this feature environment. The second challenge that we need to solve was to fetch branches that are spread across multiple repositories. I give you an example, very standard approach. We have like the backend repository, we have the front-end repository, and of course, when, as a developer, I want to test the feature number 1, I want to fetch the modification from the backend that concerns this story, and I also want to fetch maybe the modification on the front end, if they exist, for this specific story, right? Because otherwise, I can't test anything. The strategy we have used is to rely on the pull requests and the branch names. Basically, very easy. I am a front-end developer, I am a back-end developer. We use the same names for the pull request or the branch. And Jenkins, whenever he receives this information that, okay, I want to start this feature environment, he will inspect the repository, he will look for the correct branch, and he will build this branch. Okay? To simplify and to have a consistent naming, we are using the Jira ticket IDs. So basically, as a developer, I will start my branch on my pull request. I will name it the same as the Jira ticket. Everything is connected and transparent. And this way, I am able to create different configurations. If I want to build the feature number 1, in which I only have the backend that change, then I will pull the master branch of the front end. And then I can already test that everything is working as it is supposed to work. In case I want to build feature 2 that include modification both on the backend and the front end, I will fetch the modification from both sides, I will build it, deploy it, and I can use it. And this strategy can be used as you are increasing the number of repositories if you want to increase this aspect. One of the challenges that we wanted to tackle and solve was how do we instantiate these feature environments? We wanted to have something that is smooth, that is easy for the developer to work. Basically, we plug to the Jira board the instantiation logic. So basically what is happening, I am a developer, I am developing on the ticket number 1. Whenever my code has been reviewed and checked, and I want to test it by introducing this feature environment, I will just like shift the ticket to the testing column. As a result, Jenkins will create this environment. My QA will be able to test it. My PO will be able to test it. I can demo it to the stakeholders during the sprint review. Whenever everybody is happy and we consider as ready, I will shift my ticket to the ready column, and then the environment will be destroyed. Right? There is no other complex stuff to do. As a result, for this both operation, we will notify the creation of this environment by using Slack. So, hey, look, this environment has been created with this URL. You can access it whenever you want. And we also document the Jira ticket with, again, the URL that target this feature environment. Okay? Of course, we don't want to do that for every ticket. Because otherwise, it means that we create huge number of feature environments, and basically it costs a lot of money. So what we did as well is that we use this small red label, okay? It's a specific convention that we use, and in case you want to instantiate a feature environment because your modification requires it, you will put this label. If we shift to test column, it will create the environment. If you don't have this label, nothing will happen. Okay, so it's a way as well to easily like trigger or not the initialization, the instantiations of these feature environments. Couple of recommendations when you implement feature environments. You need, of course, to monitor the instances to stay cost-effective. Because, trust me, when we introduced this new toy to the development team, everybody was super excited. They start to create like 1,000 environments. They were running for like a couple of days, and of course, this is not what we want. So here as well, we have implemented some alerting and also some thresholds. Alerting means, hey, look, this environment has been running for like 3 days. Are you still using it? If you don't confirm, it will be destroyed automatically. Threshold as well is like, hey, look, we have like already 10 environments that are running. Please finish your ticket first. Close the feature environment before we create new ones. So you still need to be cost-effective in the way you handle that, despite it's super nice, because otherwise things can increase a lot. Another aspect that I wanted to mention is that as the application was growing, we have very challenging phases. We are spending a lot of time to implement data fixtures. Data fixtures means fake data that represent some business cases so that when we start this testing environment, the application is not empty, right? We want to have like orders, users. We want to have like business object in this application to work with that. And we were spending a huge amount of time to maintain data fixture, to change them as the way the data model were changing, and it was super inefficient. What we did instead is that we were pulling the production data. We were anonymizing everything, and we were taking a small amount of that, like maybe half of the databases, and basically, every time we were instantiating a new feature environment, we had fresh data that were completely anonymized from the production. It was super interesting because it helped us as well to realize some patterns, some habits that the customer had when they were using the application. To realize there were some issues because we were actually mimicking the business behavior with our data. And it helps as well to troubleshoot in a very efficient way some issue that we got without the need to have access to the production platform, which is great. Finally, recommendation that I just mentioned about is provide self-service approach, provide a platform engineering approach if you want to go this way, just like I just mentioned. You don't want your developers to have to do tricky things to use something. You want to make their life easier. And then this is why we introduce this Jira integration, so that anyone can instantiate and destroy a feature environment without the need to do some weird stuff. And of course, it helps a lot. As a benefit, the bottleneck for testing has been completely removed. The ownership in the team increased, so even junior developer, no matter if they were back-end, front-end, everybody was super excited and start to do things on their own, to test, to have feedback, and it was super positive. It was also much more transparent for stakeholders because we were able to demo quickly some aspects, right? And in a very close environment to production. So hopefully we reduce as well the inconsistency gap between it works on my machine and it doesn't work anymore on production. Finally, as a tactical move, this feature environment also helped us to implement very good end-to-end tests using Selenium. Because basically for free, we were able to instantiate and pop up an environment. We were able to test the regression against this modification environment and to get very good results. So it also helped us to introduce this end-to-end tests only on the modification, and we introduced that as a decoration for the pull request. So it means that we add like non-regression tests also in the pull request thanks to this feature environment. Conclusion for this journey. And I like metrics, I like data. So when we initially started with Gitflow on the first month, we were basically able to deploy like 5 times, 10 times per month. So basically like 1 release, 2 releases at max every month. And as the team grows, of course, it was very challenging and it was taking a lot of time. When we switch to trunk-based development with all what I mentioned, we multiplied by 3 and even 4 the number of releases that we were doing. We suddenly moved from doing a couple of releases every week to releasing basically almost every day. If we look at the numbers, 1 week we were able to deploy 13 times, meaning we were able to deploy on average 3 times per day, which is amazing. Again, when looking at the numbers, one of the top release days was we were able to deploy 6 times to production on the same day. And among this release mechanism, the defect rate that we mentioned, so for 100 deployments, 100 release, how many got an issue? Only 7% of them got an issue. So on 100 deployments, only 7 got an issue. And because we were using feature flag, we were able to quickly solve the problem without having big issues. So if we come back to this slide that I mentioned earlier, with Gitflow, we had this release time of like 9 hours with this big chunk. We were basically like struggling a lot. Moving to trunk-based development, we were able to release in like 15 minutes, very small release size, and on average be able to deploy like 2 times every day, which is super nice. So a couple of challenges that I wanted to share with you as well. Again, and to repeat and to re-emphasize, it's important to change a little bit the engineering mindset. The definition of ready changes. You start to have interesting conversation regarding like, what does it mean to be ready? And of course it changed because in Gitflow you have so many like layers that prevent you to do something wrong, and here suddenly we change this definition. The story size, the dependencies, everything takes time. It's also challenging to encourage the ownership among developers. For so long they have been like teach to work in a specific way, and suddenly they have like a lot of freedom. Finally, if you switch to this kind of like branching model, you will also impact the team structure, the way the team are cooperating together. They will probably move from component team to feature team. So the recommendation again here is like run workshop, run meetings, invest time with people, and not only with engineering teams, but as well with stakeholders, with product owners, because they need to understand what is the impact. Yes, we are releasing faster, but it's also because we are working on very small increments, small iterations. So at some point, we will need to pay back as well, right? It doesn't mean because the feature works that it's finished. At some point, we will need as well to refactor, to remove the feature flag. This is also time. Despite we have already some value because the feature is deployed and enabled for users. So we need also to have this conversation to re-explain what is happening. Otherwise, people will just assume that it's working. Important as well to challenge the sprint planning, to remove dependency and constantly refine the scope of work. Having smaller chunks is very complicated for people. It's very, very hard, and we need to challenge that constantly. Can we do smaller? Can we do simpler? Can we do differently? Is it necessary? Can we do another way? Very important to constantly like remind that. We need to monitor the trends as well and conduct retrospective to make sure that we are not tweaking and we are not losing in quality. We are not losing something. It's very important because we offer much more freedom, much more power, but we need also to check that to make sure we are not like losing something. So it's important as well to provide guardrail to encourage developers to ship autonomously. Nowadays, whenever someone enters the team as part of the checklist, he has to release at least once time on production alone. This is something we want to encourage. They need to try and they need to test on their own. And at the end, a couple of months later, people are happy. Because developers, they don't want to depend on someone else. They want to see their feature being released on production. In the past, they just did some part of the work, and this responsibility was delegated to someone else. Nowadays, they have control about their destiny, and they are very happy to be able to ship to production and to see what's going on and to visualize the value they are providing. So again, this is something that is great. Is trunk-based development suitable for everyone? Honestly, no. For the simple reason that we have different needs. If you are working on a pure software development approach, meaning you want to control your release, maybe you have different releases in parallel, maybe you want to identify some specificity because you are working on a framework, you are working on an open source project, probably trunk-based development is not for you and Gitflow might be interesting, or maybe some intermediate versions. If you are working to a product development, when you don't really care about the individual release, but instead you are more interested by the iteration and how fast you can release, probably trunk-based development could be interesting for you. So again, it's not a silver bullet. Depending on the case you want to have, pure software development versus product development, probably you want to tackle something different. Thank you very much for your attention. I really appreciate to be here today with you at Devoxx Poland. And if you have any question, I will be very happy to have them. We only have like 20 seconds, so probably with a drink outside or here on the stage. And I will also speak tomorrow. I will give a very different talks regarding how to be like an effective tech lead. It's a quickie session in room 3. And thank you very much, and see you later if you have any question.